So I'm leading a project involving scientists from IMAS in Hobart, from the Australian Antarctic Division and from the British Antarctic Survey, where we will develop models to predict the distribution of biodiversity on the entire continental shelf around Antarctica. So having this kind of information available is absolutely unprecedented. The data that we have currently for the continental shelf in Antarctica is actually really very sparse. But for a few reasons, as of very recently, we're now in a position to be able to run these kinds of models which can be validated. So we develop a model with some data, we validate it against other data, and then provided the model is well enough validated, we can then extend that model to the entirety of the shelf. So we've done some proof of concept with this work already, and it's worked extremely well for parts of eastern Antarctica, and now we're rolling it out, as I said, for the entire continental shelf. So why is this important? Well, for so much of the policy, the spatial planning that goes on around Antarctica that determines what can be done where, it really does depend on the kind of environmental impact that might be anticipated. And to be able to assess that, we need to know about what those communities look like, what those benthic bottom seafloor communities are, where they're most vulnerable, and what sort of activities we may or may not allow there. So for the moment, most of those sorts of predictions are based really not on biological data at all, but on physical data, and they're used as sort of proxies to say, well, if it's this deep, we might expect these sorts of organisms. And of course, that's better than no information at all, but it's not very reliable, basically. So this should be a major step change in the availability of knowledge, of evidence, around which groups like the CASPR, the United Nations group, can make decisions and develop policy about who does what. Now, what else? I'm just thinking what else I can say. Until now, this kind of model really has not been possible because it depends very much on a very detailed model, a three-dimensional model of the physical oceanography around Antarctica. And that information, the model output, actually has not been available until early in 2019. And these are our colleagues at the Australian Antarctic Division that have spent a long time putting together this model that will resolve at quite small spatial scale. So it's highly detailed. Again, the model is validated, so we can have a high degree of certainty of its accuracy, and that enables us to be able to make predictions about the food availability on the seafloor, for example. And that food availability, of course, not surprisingly, is a very strong determination of what is growing on the seafloor. From the perspective of an ecologist, one of the critical geostrategic questions is really about how the environment is going to be impacted by human activity into the future. So it's critical in places with sensitive environments like polar regions that we don't make a mess of those environments. So it becomes really important to have the knowledge base of what's there now and how that might change into the future, for example, with climate change or with any other anthropogenically derived stressor. So in terms of priorities, humans depend fundamentally on properly functioning ecosystems, and they certainly depend on properly functioning marine ecosystems. That's a very strong dependency that's probably not widely appreciated. So we absolutely need to understand and have a very strong evidence base for what these ecosystems look like now, what sort of dynamics they have, and also that really important question, how are they going to change into the future as a result of the sort of stresses that humans are placing them under? there's no doubt that humans are having an increasing impact on the functioning of ecological systems. And it's absolutely critical that we understand what that impact is and how it affects not just the functioning of the marine ecosystems that are being affected, but how the change in the functioning of those marine ecosystems then feeds back to influence the way that humans get through the day. So really the challenge for us as we enter this epoch, this era that's known as the Anthropocene, the era in human history that is really being strongly impacted by human activity at global scales, we need to really understand the nature of our impact on the Earth system, of which the marine side is very important. 70% of the planet is marine and marine ecosystems. So we need to understand the nature of our impact and what it is that we need to do to ensure this joint journey of human systems and ecosystems through this Anthropocene, through this period, for the mutual benefit of both. The mutual dependency is something that is probably not appreciated widely enough, and it's certainly our responsibility to ensure stewardship and really ongoing human society depends in a very fundamental way, as I've said earlier, on properly functioning ecosystems, and it's our responsibility to ensure that is possible. What we have learned from research on both poles, the Arctic and Antarctic, is that those high latitude polar systems are really quite sensitive to things like shifts in climate, to fishing pressure, those sorts of things. So we know from research in both hemispheres that we need to be very careful and very cautious about how we go forward and utilise these areas. So I think that's just a no-brainer, and the evidence there is really very clear. In terms of research, look, there's still some very open questions about the nature of particularly global change and how that might impact on high latitude systems, but also how the change in the high latitude systems is going to feed back, to affect other kinds of Earth systems. So global weather patterns are determined very much by what's going on in the ocean, and the Southern Ocean, for example, plays a disproportionate role in determining global weather. There's a lot more that we need to understand about that. Oxygenation of the deep sea happens through the overturning circulation that occurs in Antarctica, and that's being affected by the sorts of changes that we're seeing in global climate. And of course, everybody's talking about the impacts that sea level rise will have on coastal populations into the future. And that's really an open question about how quickly the Greenland and the Antarctic ice sheets are going to be affected by climate change, because that's one of the critical variables in determining rates of sea level rise. So I think there are some very big questions that research needs to get on top of really quite quickly as we prepare to adapt and to hopefully mitigate to some extent some of the effects of global change that we're driving through our own behaviours.